Hey everyone, Greg here. How are you this evening? It was a beautiful weekend in Oregon. Probably won't have too many more. I was able to get out on my bike Saturday, and I do that as much as I can before the long dark winter sets in and it starts raining and it doesn't stop for 4 months. But anyway, so we had a good week. I wanted to bring up one more point about the chi-square test chi-square test goodness of fit test. One of the things the goodness of fit test is used for is to see if a variable is distributed normally. And this is pretty important in quantitative research. So let me give you an example. Do you think SAT scores are distributed normally with the mean, median, and mode around 500, with more people getting more than that and the same amount getting less? So let's say if this is the way you believe that the SAT scores are distributed. 40% of the people get 500, 20% of the people get 400, 10% of the people get 300, 20% get 600, and 10% get 700. Now that's roughly a normal distribution of SAT scores. And if you wanted to determine whether this was the case or not, you could use a goodness of fit test and pull a sample and then put them into those categories and see if you could reject that hypothesis that the variable was distributed in those percentages, just like you did, in those percentages being a normally distributed percentages. So there's other ways to test for the normality of a variable, but that's quite commonly done, and you will probably do that when you get close to writing your paper if you do something in the quantitative area. So it's been a good week. So far, so good. Now, let's talk about the last part of the course here. There is an assignment on Saturday, as usual, and that will be due. You can send it in anytime early Sunday morning. I start working on them about Sunday at 1 o'clock. And it's okay to start working on the assignment early. Just make sure that Friday night or early Saturday morning, you go through the posts and your emails and make sure there was no new knowledge that came about and that should go in there. And I'd rather you not actually, and I appreciate this very much, don't send in the assignment until Saturday morning or Sunday morning when you're sure you've got the benefit of everything that happened during the week. There's no reason to rush it. So anyway, and there is an assignment on this Saturday night or Sunday morning. There is also a final, and you'll see in there in week 8, that is a practice final, and the real final will be virtually the same type of thing. So I go online with the PLC on Monday afternoon, and I will get you a firm timeline, and I'll get that to you. But I think what will happen is I will send you the final on Saturday night, and then you'll have about 4 days to finish it. And I don't want you to get too stressed out over it. The final is totally doable. Even if you spent at the most 30 minutes a night for 4 nights, 2 hours total, that'd probably be plenty of time for most people. And it's just straight to the point, calculations. Do you know how to do the correlations? Do you know how to do the t-test? Do you know how to do the ANOVA? Do you know how to do the chi-squares? And I'll work with you in every way I can this weekend to make sure you're prepared. But I think it should go reasonably well for everybody. So no reason to worry too much about it. But you can start looking at it this week if you'd like. Okay, so what happens this week? Well, first of all, up until now, in correlation, we were talking about the association between two variables. Could be anything. Could be IQ and your height. Okay, but we assume no causation. We're just looking for association. When we did the 2-sample t-test, we wanted to know if the mean SAT score was the same for football players as it was for musicians. So we were looking for an association. When we did the chi-square test, we were looking for associations between categorical variables. Was whether you take AP courses or not contingent upon your gender, meaning did the genders take AP courses in different proportions? That's simply all that means. So what we were doing was we were looking at associations with all of these tests. We spent the last week talking about cause and effect. And cause and effect, the way the scientific community understands it, is much different than the way we use it in everyday life. But we will look at it in the context of educational research, and we'll keep it pretty firm and to the point. So you'll be using terms like randomization. That means, did you pull sample participants from the population in a random manner, and did you randomize them to the control and the experimental group? You'll be using words like dependent and independent variable. The independent variable is the variable you manipulate to see if it will cause a change in the dependent variable. You will have words like control and experimental group. You will have words like external validity and internal validity. So this is a very good week, and it's pretty interesting. It won't have any new statistics in it. It will use the two-sample t-test quite heavily. So let me just give you a quick example here. So let's say I'm an educational researcher, and we'll keep it simple. Let's say I believe that somehow the way I have my classroom organized it will have an effect on an assessment at the end of the week on a spelling test for 8th graders. So I believe there's a cause and effect relationship here. The independent variable is how the classroom is organized in terms of furniture, daily activities. The dependent variable is the measurement on the spelling test or whatever we have. So let's say we were going to set up an experiment. Okay, so here's our experiment. Now mine's a little different. Let's say I believe that eating carrots will cause a rise in test scores for 4th graders. So I'm going to set up, first I'm going to do what's called randomization. I'm going to take randomly from the population of interest, from my target population, 2 groups. And then I'm going to randomly put them in the control and the experimental group. After I put them in the control and the experimental group, I'm going to give them each a pretest on the dependent variable, which is the spelling test. And I would like to see, hopefully, a very high p-value, meaning there's very little difference between the control and the experimental group. That's going to mean I did a good job of randomizing the groups and taking out any possibilities for confounding variables, because the groups are essentially equivalent. After that, I'm going to manipulate the independent variable, which is whether the students ate carrots or not. In the control group, the students will have not had any carrots. In the experimental group, they will have had a whole carrot. So that will be my manipulation of my independent variable. After that, I will administer a post-test to measure the dependent variable again. And then in that case, if I were to find a very low p-value, meaning there is a difference between the mean score on the control and the experimental group, I might consider the fact that carrots were the cause of the increase in test scores, because there would be no other confounding variable to account for that. That's what the control group does, is it eliminates all, they're called confounds, which are rival explanations for the change in the dependent variable. One thing to keep in mind is